This is section 3.1, beginning chapter 3, which is on derivative shortcuts. It's the longest chapter. Okay, so 3.1, adjust the camera here. So we have to go up to problem 61. So let me go ahead and pull on the text. So these are derivative shortcuts. Topic is differentiation rules. It's the bottom of page 171. All right, so here's on page 180. We have to go up to problem 61. Finding derivatives. And now we're using shortcuts. So for the most part, from here on out, you don't have to do limit h approaches 0 of f of x plus h minus f of x all over h. Yeah, quick word about normal line. The normal line is perpendicular to the tangent line. Okay, so normal line means perpendicular to tangent line. Okay. Some more. 57, 9, 61. And I think that's it. All right, so derivative rules. Okay, first, what if you have a constant? F of x is a constant, y equals a constant is a horizontal line, therefore the slope is 0. So f prime of x is 0. So derivative of any constant function is 0. How about a linear function? F of x is mx. Well, you can use the limit definition. F prime of x is limit h approaches 0. F of x plus h is m times x plus h minus mx all over h. Limit h approaches 0, mx plus mh minus mx over h. Mx cancels out, h cancels out. So I have limit h approaches 0 of m, which is m. So the derivative of mx is just m, and that's logical. From algebra 1, the slope was m. Derivative means slope, so it's m. Okay, power rule. You can do the limit definition. You can show that the derivative of x, which is x to the 1, is 1. Derivative of x squared is 2x. We did that in the previous chapter. Derivative of x cubed is 3x squared. Derivative of x to the 4th is 4x cubed. I write this just to follow the pattern. 1 is 1x to the 0. So in general, derivative of x to the n is n x to the n minus 1. So derivative of x to the n, x to the n prime is n x to the n minus 1. This is not a proof. We will prove that in a future section. Okay. Some other notation for derivative, y prime, f prime of x, also dy dx. It looks like dy over dx. We will normally just say dy dx. Okay. They all mean derivative. Okay, so example, the derivative with respect to x, d dx means derivative with respect to x. If x to the 6, 6 comes down, drop down 1, 6x to the 5th. X to the 100th prime, 100 x to the 99. Okay, power root n x to the n minus 1. Okay, y is x to the 2.3, y prime is 2.3, x to the 1.3. Okay, so f of x is radical x, which is x to the 1/2. F prime of x is 1/2 x to the negative half. We write it algebraically as 1 over 2 radical x. But 1 over x is x to the negative 1. So dy dx, that means derivative negative x to the negative 2, negative 1 over x squared. And we have the constant multiple rule. If you have a constant times a function, the derivative is the constant times the derivative function. And here's the proof by using the limit definition. Y prime is limit h approaches 0 of k f of x plus h minus k f of x all over h. Factor out the k. Limit h approaches 0 of k f of x plus h minus f of x all over k. Property of limits says the k can come in front. So k limit h approaches 0 f of x plus h minus f of x all over h, or k f prime of x. Okay, summarizing, the derivative of a constant times a function is the constant times the derivative of a function. So for example, if you want the derivative of 7x cubed, it's just 7 times the derivative of x cubed, which is 3x squared. 7 times 3 is 21x squared. So a shortcut for something like this is just go 7 times 3 is 21, subtract 1 here, 21x squared. Another example, f of x is 4x to the 5th. just go 5 times 4 is 20, x to the 4th power. Okay. D dx, the derivative with respect to x of 1/2 x squared, is just x. 2 times 1/2 is 1. Coefficient of 1 means don't even write it, and then x to the 1. Okay, then we have the sum and difference rule. The derivative of a sum is a sum of the derivatives. Derivative of the difference is a difference of the derivative. So f of x plus g of x prime is f prime of x plus g prime of x, likewise for a subtraction. So if you have something plus something, like y equals x squared plus 5x, what's the derivative of the whole thing? Just give me the derivative of this, 2x, plus the derivative of 5x, which is fine. Okay. But y is x squared minus 5x plus 6. Just give me the derivative of this, 2x, plus the derivative of this, -5, plus the derivative of 6, which is 0. So just stop right after that. Okay. Just a verification of the sum rule. Okay, f of x plus g of x prime, limit h approaches 0, f of x plus h plus g of x plus h minus f of x plus g of x all over h. Okay, rewriting this, limit h approaches 0, f of x plus h minus f of x plus g of x plus h minus g of x all over h. Limit of a sum is the sum of the limits, so limit h approaches 0, f of x plus h minus f of x all over h, plus limit h approaches 0, g of x plus h minus g of x all over h. And this is f prime of x plus g prime of x. So in short, the derivative of f of x plus g of x is f prime of x plus g prime of x. Similarly, for f of x minus g of x, it works pretty much the same way. You're not responsible for this proof. You're only responsible for knowing the rules. And one more derivative in this section. What's the derivative of e to the x? So e to the x prime is limit h approaches 0, e to the x plus h minus e to the x all over h. I can rewrite e to the x plus h as e to the x times e to the h. Factor out an e to the x here. So limit h approaches 0, e to the x times e to the h minus 1 over h. I can take out a constant. I know that doesn't look like a constant, but e to the x is constant as far as h is concerned. So e to the x comes out. So if I can find out what this limit is, then I got it. It's e to the x times whatever this limit is. Okay. So limit h approaches 0, e to the h minus 1 over h. Well, I'll just make a table of values. There's no algebra you can do. So I plug in negative 0.1, negative 0.01, negative 0.001, 0.95, 0.995, 0.9995, and then approaching 0 from the right, 0.1, 0.01, 0.001, 1.05, 1.005, 1.0005. So it seems like the limit turns out to be 1, and it is. So numerically, limit h approaches 0 of e to the h minus 1 over h is 1. So therefore, the derivative with respect to x of e to the x is e to the x times this limit, which we found to be 1. So it's e to the x times 1 or e to the x. Bottom line, the derivative of e to the x is e to the x. Again, you're not responsible for any of these derivations. I am. I'm just showing you what the result is. So the derivative of e to the x is e to the x. And a word of caution, that means the derivative of e to the x is not x e to the x minus 1. Watch out for that. Okay, some people think it's the power root. It isn't. Okay. Okay, so here's a made up function. Y is 6x cubed minus 12x squared plus 5x minus 4e to the x plus 7. What's the derivative of the whole thing? Well, it's the derivative of this plus the derivative of this. Just go on down the line. So derivative of this is 18x squared minus 24x plus 5 minus 4e to the x, and the derivative of 7 is 0. So we're done there. Okay. Okay, and just so I can show you this in text, again, you should know that I'm going fairly rapidly, fairly quickly. That's just to make the videos shorter, and you can always pause, rewind, fast forward as much as you want and get any speed that you want. Okay, page 172, derivative of a constant is 0. Derivative of x is 1. We get mx. Read that as an A. Power root. Page 173, derivative of x to the n is n, x to the n minus 1. And constant multiplier rule. The derivative of a constant c f of x, I used k, same thing. Take out the c times the derivative with respect to x of f of x. Sum rule. Derivative of f of x plus g of x is derivative of the first plus the derivative of the second. Okay. Similarly, for a difference, derivative of f of x minus g of x, derivative of f minus the derivative of g. And the derivative of e to the x is itself. Okay. All right, so we'll go to work on some of these problems. First ones are pretty straightforward. Number 3, 2 to the 40th is a constant, therefore its derivative is 0. Number 5, derivative is 5.2. Derivative of that is 0. Number 7, the derivative is 6t squared minus 6t minus 4. So pretty straightforward. Number 9, multiply it out before you take the derivative. So go x squared minus 2x cubed, and that should be pretty straightforward after that. Okay. Number 11, g of t is 2t to the negative 3/4. So the derivative, multiply that by that, negative 3/2 t to the negative 7/4. Okay, you are allowed to leave the answer with a negative exponent if the original had negative exponents. So we can stop right there. Okay, f of r is 5 over r cubed. Treat this as 5r to the negative third. We don't know how to handle quotients yet. The next section we do it. All right, so the derivative is negative 3 times 5 is negative 15 r to the negative 4. Rewrite it as negative 15 over r to the 4. Okay, here the original problem did not have any negative exponents, so I don't leave the answer with negative exponents. Here the problem started with a negative exponent, so it's okay to leave the answer as a negative exponent. 23, I'm dividing by a square root. Treat this as x to the half and then divide. X squared divided by x to the half is x to the 3/2. 4x divided by x to the half is x to the half. And then 3 over radical x is 3x to the negative half. Okay. All right, so dy dx, 3/2 x to the 1/2. Half times 4 is 2. X to the 1/2 minus 1 is negative half. 3 times negative half is negative 3/2, x to the negative 3/2. Okay, and we should not have any negative exponents. So 3/2 x to the 1/2 means radical x, plus 2 over radical x, it's in the denominator because of the negative, and minus 3 over 2x to the 3/2. All right, 33, the equation of the tangent to the curve. Okay, so to give you a point, we just need the slope. Slope means derivative. So the derivative of this guy is 6x squared minus 2x. Plug in 1. So how come you don't plug in the 3? 3 is for y. The expression doesn't have any y, it only has x. So I plug in 1 there, 1 there. 6 minus 2 is 4. So point, slope. Y minus y1 equals m times x minus x1. All right, then we have a second derivative. Well, second derivative is just a derivative of the derivative. So y double prime, f double prime of x. We're using the Leibniz notation, L-E-I-B-N-I-Z, the D stuff, like dy dx, that's called the Leibniz notation. Leibniz is one of the co-founders of calculus along with Sir Isaac Newton. Looks like d squared y over dx squared. That's what it looks like, so that's how I'm going to say it, even though you're not necessarily squaring anything. Okay, this is just another way of saying second derivative. Okay, so give the second derivative. F of x is 2x minus 5x and 3/4. So f prime, first derivative, 2 minus 5 times 3/4, 15/4, x is negative 1/4, which is 2 minus 15 over 4, x is 1/4. Double prime, differentiate this. Differentiate means take a derivative. Okay, derivative 2 is 0. And negative 15 over 4 times negative 1/4, 15/16, x to the negative 5/4. So final answer is 15 over 16, x to the 5/4. Okay, 49. Okay, if you're given a distance function, the first derivative is velocity, second derivative is acceleration. And you physics people may have already heard that before. Okay, so first derivative is velocity, second derivative is acceleration. So first derivative is 3t squared minus 3, second derivative is 6t. Okay, part B, they ask for the acceleration at time t equals 2, plug in 2, 12 meters per second squared. 3, C, 3t squared minus 3 equals 0 means the particle's at rest. Factor out to 3. Factor some more, 3 times t plus 1t minus 1. So t equals 1 second. We're assuming that t can only be positive. Okay, and if I plug in 1 for the acceleration, I get 6 meters per second squared. Quick word about units. So we have meters and seconds. Distance is meters. Velocity is meters per second. Acceleration is meters per second squared, which means meters per second. Okay, so distance function S of t, We don't use d for distance because d stands for derivative. Then velocity is the first derivative, s prime. Acceleration, a, is s double prime of t, or you could say it's v prime, the derivative of velocity, which is the derivative of the derivative. Okay, so if distance is in meters, time is in second, then distance s is meters, velocity is meters per second, acceleration is meters per second, or meters per second squared. Okay. Okay, 55, they're asking for a horizontal tangent. Horizontal tangent means slope equals 0. So I take the derivative and set it equal to 0. 6x squared plus 6x minus 12, set it equal to 0, factor out of 6. Factor further, x minus 1, x plus 2. So x equals 1 or negative 2. Okay, find the y coordinate by plugging in f of 1, 2 plus 3 minus 12 plus 1 is negative 6. So 1 comma negative 6. And do the same thing with negative 2, plug in negative 2, blah, blah, blah. So those will be the points at which you will have a horizontal tangent. Okay, 57, it says, show that there's no tangent that has a slope of 2. So I take the derivative. Derivative of 2e to the x is itself. Derivative of this is 3. Derivative of this is 15x squared. And you can tell 3 is positive. This is greater than 0. This is non-negative. So this whole quantity has to be greater than 3. It can never equal 2. 61 asks for a normal line. Okay. So first parallel to 2x plus y equals 1. So find the equation of a line that's parallel to 2x plus y equals 1. So y equals negative 2x plus 1, that means the slope is negative 2. So the slope is negative 2. Therefore, the slope that I want, m wanted is 1/2, the negative reciprocal, right? Remember that the negative reciprocal of this slope will give me the normal line. Okay, so now I find the derivative of x to the half, 1/2 x to the negative half, or 1/2 radical x, set it equal to 1/2, the slope that I want, cross multiply, 2 equals 2 radical x divided by 2, 1 equals radical x, square both sides, x equals 1. So the ordered pair, plug in 1, I get 1, 1. Okay, so the answer is 1, 1. All right, so that was section 3.1.